Norgren is a global fluid controls manufacturer who make products for rail, medical and automotive sectors. We have quite a diverse product range. My name's Chris Narborough. I'm a design engineer. I work for the advanced engineering team. My main role is to develop new products for the waste heat recovery systems in trucks, of which the exhaust diverter valve that we're looking at is one of those components. The waste heat recovery system itself can save as much as 7% of the fuel used.
We set up a waste heat recovery team about 18 months ago because we identified the fact there was a trend within the commercial vehicle industry that they're looking at improved efficiency of truck engines. My name is Patrick Williams. I'm a technical manager. My main involvement was the simulation and some of the upfront conceptual design, and therefore we spent a lot of time working with simulation CFD.
My name's James Robinson. I'm the UK Technical Director. One of the major benefits that the Autodesk software gave us was the ability to prototype things digitally and also to simulate the performance of the product. So using Inventor and CFD, we were able to track the fluid flows and understand whether or not we were going to see the right characteristics.
The Autodesk tools were integral to the work that we did to try and understand the fluid system, to make as many changes as we can at an early stage when we're only looking at 3D CAD models, and then when we produce a single final prototype, it should in theory match the calculations that were done. And in this instance we did produce a single prototype design and it met all of the requirements and the specification, so we had absolutely no issues with it.
A couple of major challenges that we faced on the project. One was a very short lead time, but also due to the value of the prototypes. What we wanted to do is make sure we could deliver a prototype that worked first time. We didn't have the luxury of being able to produce several prototypes, so we needed to put far more confidence in the simulation of the product up front, and the Autodesk software allowed us to do that.
It definitely saved us a lot of time being able to do the CFD and the FEA rather than having to build and machine prototypes. We were able to analyse the design at a very early stage, so I think we probably saved a couple of months in the development cycle in that.
The Autodesk software has allowed us to communicate our CAD data through a standard platform across the group through our supply chain. It's helped our tool makers to design tools faster by using 3D modelling.
We've had this on truck engines running at over 800 degrees C and we've seen no issues at all with it, which demonstrates how good the design is. So it's a great moment in seeing that sort of working the way it should do with no actual issues at all.
What I'm really proud of is obviously firstly the team, but also the fact that we've been able to come up with something new and innovative. We have a patented design, but also the fact that we were able to achieve what we have in such a short period of time.